Okay, notes on logarithmic functions. So this is, you've done logs before? Did you do logs? Let me ask that differently. Have you done logs before? No. Okay. From the top then. All right. 2y equals 4, 2y equals 8 can be solved, like we can do those problems by math, by algebra. The more specific word I was thinking, I don't know what's supposed to go there, but I would say by common bases, right? 2 to the y equals 2 cubed, so y equals 3. So you get a common base, you can solve those problems. There was one of those on the most recent test. It was kind of a pain because there was like 4 different numbers that you had to get to a common base. But to solve 2 to the y equals 6, that doesn't really work because it's like, well, 2 to the what would be 6? Like, I mean, I guess there's a number, but it's not a nice number. It's not an integer for sure. That's where logs are needed. More on that later. So that's sort of where we're headed, to be able to figure out if 2 to the y equals 6, well then what is y? Well, next week we'll figure out how to get there. Okay, definition of logarithm of base a. Okay, so I guess the first thing we should say is there's the base. It's written slightly smaller, slightly lower, like a subscript. Log base a of x equals y. Maybe we should make sure we know how to say that. Log base a of x equals y. Just like how to talk math. Log base a of x equals y. What that means is, or a different way to say that is, a to the y equals x. So our main job today, and by main I almost mean only, is translating a log statement into an exponent statement. Translating a log statement into an exponent statement. Because you're pretty familiar with exponents, or at least you're certainly more familiar with exponents than you are with logs. Here's the shortcut. It's some people call it the fishhook method or the loop-de-loop method. You start at the base, right? Like any building would start at the base, and you loop around. There's our fishhook. So c to the r equals w. So start at the base, loop around, and the first few times you do this, like you're gonna like physically draw it.
Wait.
You don't have to, but most of you are.
C to the R. Why do you draw the A to the W?
Because that's the order we go. C to the R equals W.
Oh.
And again, the first few times you do it, you're probably going to draw it. When I'm away from this for a while and we come back and we need it, like in pre-cal or calculus, like I'll usually draw it the first few times just to get my brain back thinking what's going on here. So anybody want to take a stab at the next one, exponential form of this one? F to the k equals g. Fishhook around. Oh, feeling confident. Let's pick on somebody for the last one. Logan, what do you think the last one is?
B to the T equals A.
Got it. B to the T equals A. So that's the main thing for today. If you get the fishhook method down, you can answer all the questions today. Start at the base, fishhook around. Evaluating logs. Well, again, fishhook. Think about the fishhook. This means 2 to something equals 16. Well, the answer's there on the right, but so what needs to go in the blank here? 4. So log base 2 of 16 equals 4. Okay, oh, we don't give you the next answer. 10 to the what equals 10? 1. So log base 10 of 10 is 1. Fishhook around. Aaliyah, what do you think goes in this box? 3 to the what would be 1? One third would be a cube root. Did you hear what she said? 0. Because anything to the 0 is 1. So it is 0. Good job, Nicole. Or Karis. Or Ellen. Or Leah. Whoever.
I'm not going to take your credit, girl.
Now we drop off the because altogether, but it's still the same thing. 6 to some power equals 216. And if you don't have a calculator, you know it's going to be an integer. So 6 squared is 36. 6 to the third is 216. Dante, what about log base 8 of 64? Equals what? 2. Why did you say 2?
Yo, what?
8 squared is 64. So log base 8 of 64 is 2. Powers of 13. So 13 to something equals 169 squared. Well, the answer is 2. The reason is 13 squared is 169. So again, I'm just fishhooking all of these problems. They're all fishhook issues. Some might be harder than others, but it's still a fishhook issue. Reese, 5 to what is 1/5? -1. So when you get the hang of these, maybe you stop actually drawing the fishhook, but some of you will draw the fishhook from now through your calculus time. And that's fine, if that helps you see it. Tell you what, why don't you try that next set there. Next set of 6. I'll hit pause, you see if you can work through those. Some of those are kind of tricky, but give it a again, you got to know your exponent rules really well so that you can use the exponent rules in reverse, basically. Logs and exponents are inverse functions. They undo each other. So you got to know exponents well so that you can go backwards with them. All right. Common log, it's a fancy way of saying the unwritten base. If there's no base there, I mean, there is a base there, it's just not there, so it's not written. And so we add this to our list of unwritten numbers in math. Let's say we had, let's see, what's the exponent on x?
1.
1, but it's not written there. What's the root of, if I write it like that? 2, right? So I don't have to write 2. So we're familiar with, there are unwritten numbers in math, right? Like, that's x to the first, that's the square root. We don't write those because we all just know what that unwritten number is. Well, it's the same thing here. The log, if you have an unwritten base, the base is 10. But the base is not written. So add this to your list of like hidden numbers in math. Let's see, 10 cubed is 1,000. That's right. 10 equals 0.01. So 10 to something, I'm going to rewrite 0.01 as 1 over 100. That helps me see that better. So it's -2. Right? Negative flips it over, and 10 squared is 100. Okay, so the main point of this is the unwritten, the hidden log, or the hidden base anyway, is 10. So you add that to your list of hidden numbers that you know. All right, some more practice here. Let's just pick on some more people. Get through a bunch of people today. Yeah, some of these are tricky though, so gotta pick people who are in the room. Let's do the first three. Kennedy, how about log base 4 of 16? 2. And I've sort of transitioned away from drawing the fishhook, but my brain is still looking at that and thinking about the fishhook. 4 to something equals 16. Cody, log base 5 of 1? 0. 5 to 0 is 1. Preston, you get our first invisible base there. What's log of 100? 2. Because 10 squared is 100. Alright, now we get to some challenging ones here. Oh, perfect. I got some people who can do challenging ones. You got this. Allie, what's log base 4 of 2? 1/2. Very nice. 4 to the 1/2 is 2. Jack, I'll confess I gave you what I think is the hardest one.
Not -0.
There is no such thing as -0. Or it's the same as 0. So it's not that. 3 to the 0 would be 1, not -1.
0 would get you 1.
That's right. So clearly you're thinking the right thing. You're thinking 3 to what equals -1. And there's a certain type of answer to math problems that students don't like.
Is it imaginary?
It's not imaginary.
It's not possible.
It's just not possible. So that's really cruel. Give Jack one that doesn't even have an answer. Wasn't nice. Nicole, do you know what yours is?
X plus 2.
It's just x plus 2. Very nice. This means 4 to something equals 4 to the x plus 2. Well, I don't know what x is, but if these boxes are supposed to match, then I guess the answer is x plus 2. Very nice. I solve, but the hint is rewrite in exponent form first. So as soon as you do the fishhook, some of these are really easy, like the first one. Some of them require a little bit of thought. So what to the 5th is 243. I mean, we don't have a calculator, so it ought to be something we can figure out. It's 3. And then that last one, still fish hooking, so 5 to the 0 equals x minus 4. So 5 to the 0 is 1. Add the 4 over, x equals 5. So there's 3 or 4 different things we can do, but they all get back to fish hook, fish hook, fish hook, and know your exponent rules. The next page is the assignment, and I guess it looks like a lot because there's 34 of them, but they go really, really quick. In fact, let's do the first, just because I want to call on more people. Let's do the first 4 together, because if you get the first 4, you can get the rest, because that's just fish hook, fish hook, fish hook, fish hook. Didn't quite get to everybody today. Ethan, how about that first one? Just rewrite it as an exponent. That's all you have to do.
Q to the power R is P.
Q to the R equals P. Marina, how about number 2? Yep. And again, we're not solving these. I don't know that we could solve them. All we're doing is practicing rewriting. Megan, number 3?
Is it y to 15 x?
Yes, it is. Karis, number 4?
M to the n equals 1.
Yep. Okay, now the next set, maybe, I don't know that we did any of these. It's kind of going backwards. Joaquin, can you rewrite that one as a log? You kind of have to use the fish hook in reverse. And maybe it's helpful to start writing it.
Is it log 4 equals or 64 too?
Log base 4. I'm going to fill it in kind of the weird order here. 4 cubed is 64. That's what you said, isn't it? Yeah. So I write it in the wrong order because my brain is still thinking about the fishhook. Carson, how about 3 squared equals 9?
Log base 3, 9 equals 2.
Yes, because 3 squared equals 9. And last one, that way we've called on everybody. Adeline, how about 17 to the 1/3 equals x?
Log 17 x equals 1/3.
Yep, because 17 to the 1/3 equals x. Fishhook, 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 fishhook. 30 times, 34 times,
Mr. Wool,
and you'll be done. Yes.
if it's any negative numbers, just outlaw it.
If it's any negative number, be more specific on that. So if you're trying to take the log of a negative number, that's not possible. Kind of convince yourself of that. Like, most of these you're probably not going to rewrite as exponents. You're just going to do the fishhook in your head and figure out what the answer is. But when you get to tricky ones, that's when it's maybe worthwhile slowing down. 7 to what equals negative 343? That doesn't work.
Can the log be negative?
Can the
The base be negative, like 7?
no, it shouldn't be. Are there any that are like that?
No.
Okay. Yeah. The base can't ever be negative. We don't even know is the answer. All right, again, 34 problems, but some of you are probably halfway done already.